Hi, everybody. This is Mr. Folly, and welcome to Podcast 3.2, where we're going to talk about the ideal gas theory. So, we round and estimate gases. Ideal gases don't exist. Some gases are more ideal than others. So, we're really focusing on ideal gases. So, let's take a look. Kinetic molecular theory of gases. This explains how we think of gases. It's a generalization, but it's 95 to 99% true. Like NBA guys are tall. Yeah, they're tall, right? This guy's tall. Ooh, this guy's tall too, and this guy's tall, and this guy, well, he's a ref. He's probably not that tall. And that kids in High School Musical actually sang, "Oh, I love that song." Oh, June. You need to know the kinetic molecular theory. So this explains why gases do what they do. We assume the following are always true for gases. Particles are in rapid, random, straight line motion. So if you remember in the Ring of Ping, no duck, duck, goosing, right? And they kind of move all over the place. And remember we talked about, when we talked about the smelly particles and how they would bounce and go all over the place. So rapid, random, straight line motion, the random is because they bounce off of a bunch of things, other gases. Particles are not attracted to anything. Nothing at all, not even Noah. Okay. Particles bounce off of each other and the container, but do not lose energy. And this is something that, if you thought about it, if you have a super bouncy ball and you drop a super bouncy ball, I guess my arm's pretty high, it falls and goes boing, 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 boing. They would bounce forever and bounce right back, boop, 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 so they don't lose energy. And particles are point masses. So we'll talk about that in a second. So particles are in rapid, random motion. Gases never stop. Gases always move, but can move faster, hotter, or slower, colder. But if it is a gas, it is moving. This creates pressure because it hits the container. Particles are not attracted to anything. This means they don't clump up, they spread out, diffuse. This means they don't wait by the door to leave the container. Okay, so they don't have like a goal, they're not like arranging themselves to do something. Oops. Particles are point masses. Groups of gases have volume. Individually, particles have no volume. Can 100 ants fit in your house? Yes, it doesn't matter the size of the ants. Can 100 ants fit in Illinois? Yes, it doesn't matter the size of the ants. But if I said, can 8 people fit in your car? Assuming we're not trying to be super safe here. Well, on this one, it depends, right? Right? But these other ones, ants, right? So the reason why is gas particles are so small, the particle size doesn't matter. Like the size of an ant compared to a house. Okay. Dang review. Ideal gases are just like Disney princesses. They're unattractive. Disney princesses don't have any friends, right? Belle doesn't have any friends. Plates don't count. Jasmine doesn't have any friends. Tigers don't count. They really have no friends. Isn't that sad? Gases are small. They're not giants. They're little teenage girls. Gases are like Disney princesses. They're constantly moving. They're singing, swimming, and whatever it is that Mulan does. And Disney princesses never lose energy. They don't die like Bambi or Mufasa. They go on forever. So that is it. We are done. We are out of here. Toot, 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 toot. Wait a minute. You're not done. What you need to do is make sure you write all this down. Rewind. Pause. Get it all in there. Toot, 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 toodles.